So I'd like to talk to you about conditional probability with tables. Now, the weird thing is this comes fairly early in the Stats 1 course, but it's actually the same as that very last section, that last module in the course called conditional probability, where you learn to take the intersection divided by the condition as the mathematics behind it. It's just disguised a little bit. So I'm going to try to take a more sort of common sense approach to help you understand how to deal with conditional probabilities when you have a table. But I also might take a few divergences to later in the book to compare it and show the connection to the traditional conditional probability that you learn at the end. So, right, we've got our usual kind of table. Um, I might eventually expand this a little bit, but let's just start with this kind of data. Let's see, I think I need one more. Yeah, I think I need one more row here. So let's just start with men and women. No, you know what? Let's start with the total. Let's start with a total, and I'll make it smokers and non-smokers. So here's the people who smoke or smoked, and then here's the people who never did. All right, it could be any two categories. It's just easier to talk about smokers, non-smokers. Okay, and let's say um, you're being asked a question about, hey, how many were? What I'm going to try to do here is make the numbers pretty small so you can follow my percentage work. So let's say that there were 8 smokers and 12 people who never smoked, right? I mean, if I just ask you what percentage of people were never smoked, right? It's easy because what you're doing is you're saying, oh, 12 never smoked, right? Probability of never equals, right, the size of never divided by the whole sample space, right? You wouldn't divide by 8, you divide by the 8 plus 12, which is the total, right? So there's another total, right? So just to answer the question, what percentage of people never smoked, you're doing a row probability. You're just not aware of it. It's just a natural thing that you're doing, 12 over 20. And, I'll convert to percentages because that's often how things are show up on the exam or in multiple choices. So now what if I give you details, right? Now what if I give you the fact that I have details about males and females, right? And what if, let's see, what if my data here is something like, something like that. And here, let me swap this around just for fun, like this. Okay, I'm kind of pulling numbers out of a hat. Right. So first of all, right, we can ask a bunch of questions here, right? Right. So actually, I'm going to have to make the numbers a little bit different, or we're going to get some confusion. So we'll probably need a calculator, or I'll just talk in fractions. Let's make it 5 here, and let's shrink that down to 7. So what if I asked you the question, hey, what percentage of males were never smokers, right? Well, that doesn't have anything to do with the 60%, right? That was the percentage of humans in the sample that were never smokers. What's the percentage of males that were never smokers? Well, honestly, right? You think about it, right? What percentage of males were never smokers? Well, do you need any of the sorry. Do you need to see any of the material down below? Do you need to see any of that to answer the question, what percentage of males were never smokers, right? What percentage of males? Oh, conditional probability. I'm given the condition that the person is male. There are only 9 males, right? So the way I answer it is, right? I answer it by saying, okay, you want to know the probability that a male is a smoker, is never a smoker, right? So the old-fashioned way, sorry, the way from the end of the book, right? We've been given male. We've been asked, hey, what percentage of males never smoked? So now male becomes the given. So never intersect a male is the top of the fraction, and the total number of males, the condition, is the bottom of the fraction. But we kind of already knew that by looking at the table. Do we need to know how many females there were to answer the question, what percentage of males never smoked? So in this case, we need to figure out row probabilities. Please don't get hung up on row versus column, because if I put smoking and never smoked on the left and male and female on the top, it would have been column probabilities. So do not get hung up on whether it's a row or a column. Get hung up on the condition. If they ask you a question where the condition is male, that straight line of males is the only thing you look at, whether that's vertical or horizontal. So here we go. We're looking at the question, what percentage of males were never smokers? Well, there were 9 people who were male in the sample, and 5 of them never smoked. So, I said percentages, but I don't want to spend too much time converting to percentages, so we'll just leave it there. Boom. 5 over 9. Don't make it hard when it's easy. Now let's go back to a very different question. What if the question is, hey, what percentage of smokers are male in this sample? What percentage of smokers, right? What percentage of smokers are male? Oh, that's interesting. When they ask you a question about smokers, again, out comes the box to cover up everything else. We don't need to know anything about non-smokers and totals to answer a question about smokers. What percentage of smokers are male, right? Well, that's the number of male smokers divided by the total number of smokers, 4 over 8, 50%. And again, that's exactly the way old school or later in the book, conditional probability, right? The question was, what percentage of smokers are male? So you're being asked about gender and you're being given the condition of smoker. So that probability of male vertical line, right, given smoker. And that would mean that smokers is the bottom of the fraction and that male and smoker is the top, right? That's the formal way to do it. But the informal way of going, oh, when they are interested in smokers, I better only compute column probabilities because smoker is a column here, right? So don't get too hung up on the details of row versus column. Get hung up on the kind of question you can ask, right? So what percentage of smokers are male? That's a question that takes their smoking condition and asks questions about their gender, right? So the amount of the smoking history of people by gender, well, by gender means we want to compare the two genders. Well, if you want to compare the two genders, you'd better do two separate computations for the two genders. So you'd better convert this to row probabilities, right? What's the status of the of smoking based on gender? Oh, based on gender, then I'm going to ignore the female in total to figure out the male, what percentage of males smoked, what percentage of females smoked. Well, that's a row probability. Compare by gender. Compare smoking status by gender. The bias, the given, so it's row probabilities. Versus the questions that go the other way around. Let's compare gender by smoking status. That means you're going to contrast the smokers with the never smokers and ask what percentage of them were either gender. Compare smoker status with respect to gender. Oh, okay. That means vertical column, right? The by whatever is the given condition, and that tells you whether it's row or probability. Sorry, row or column. So just try to kind of break it down by common sense. And if it gets hard, like, wait, compare smoking status by gender? Well, then just think about by gender. So they want to know the smoking status of males. Oh, well, that's a row probability to figure out smoking status by of the males, and then compare that with smoking status of the females, right? How about never? 5/9 for the males, and you can see it's 7/12 for the females. Different fractions of never smokers for each gender. So that's comparing the smoking status by gender. Now compare gender by smoking status. What percentage of smokers are male? What percentage of never smokers are male, right? What percentage of smokers are male? You need to take the 4 divided by 8, right? What percentage of smokers are male? What percentage of never smokers are male, right? It's about the smoking status being given. And that means you use the smoking status as the conditional probabilities, in this case, conditional column probabilities. So there you go. That's a way to sort of think of it in practical terms. And if you ever get confused about the questions, just kind of split the table up. Take a look at what they're asking and go, oh, to answer that, I'd have to do the male percentages versus female. And then you'd know what to do. Or go, oh, to answer that question, I'd have to divide up the smokers from the non-smokers and do those two computations separately. Aha, that would be column probability because these two computations are being done separately. All right, I hope that made conditional probability with tables a little more clear. And I also hope it helped you connect it to a little bit more complex subject of conditional probability as presented with the formulas in Module 12.